Hey guys, hope you're well. Here we have grade 12 maths, paper 2, November 2024. If you want to download the paper, just check the description below. Here are all the questions we're going to do, but I'm going to break them up into separate parts. So, yep, let's get started. Tell us that at the beginning of a season, the coach of a junior boys rugby team records the weight in kilograms of 15 players in his team, and then also the number of push-ups that they can do. So for example, here you have a 27 kilogram learner, and that learner is able to do 20 push-ups. Another example, here we have a 57 kilogram person who can do 8 push-ups. Then the same information that we see here is then put on a scatter plot. For example, if you look over here, we can see the x is 34. So we go up at 34, which would be here, and then the y is 26, so that would be here. So you go across, and where those two intersect, we can see that there is a dot there. And so, yeah, they've just taken this information and they've put it onto the scatter plot, and then they've also gone and worked out the equation, the least squares. First question says, determine the equation of the least squares regression line. So that's easy, y equals to a plus bx. You then do it all on your calculator. So you have to put your calculator into stat mode, and then you're gonna get options. You can either choose, well, you're gonna get given options like 1 minus VAR or a plus bx. We want to use a plus bx because this is a grade 12 kind of question, whereas this one over here, that's more for like mean, mode, median, more like grade 11 kind of stuff. Once you press a plus bx, you're going to get two columns on your calculator, x and y. So you just go fill in all the x values and then all the y values. So yep, once you've got all those values, then what you do is you're going to press AC on your calculator, then you're going to press shift 1. And then we're not going to go to VAR, that's more for grade 11 kind of questions again. We're going to go to REG or reg, which means regression. You can see how we see the word over here, so you press that number. And then you can see there's A, B, R. The R value is actually going to come in the next question. So we might as well just get all of that now. But for now, we need the A and the B. So go ahead, press A, or the number that chooses A. And then you're going to get A as 39,46 if you round to 2 decimals, and then press shift 1 again, go press the regression again, and now we're going to get the B value, and that's going to be negative 0,59. If you're not getting the same values, then you've just mistyped one of these numbers, and then so then we can just go fill this in. So y equals to 39.46 minus 0,59 x. Then for question 1.2, you're just going to get the r value on your calculator. So you just go shift 1 again, back to regression, then find the r value. And if you round that to 2 decimal places, it'll just be negative 0,80. This question now says, the coach uses the least squares regression line to set the target for the minimum number of push-ups by each team member according to their weight. Predict the number of push-ups that a member of the team who weighs 29 kg should do to meet the target. Okay, so we found in that formula that we got 39,46 minus 0,59 x. And so the coach wants us to use this formula now to try predict how many push-ups a 29 kilogram person should be able to do. So we'll go, remember that the weight is in x, so they gave that to us. So we can just type in the x as 29, and then you can go and calculate that, and we get 22,35. And then I thought that, you can't really do a 0.35 push-ups, so I thought maybe we would have to round up and say 23, but then I checked on the memo and no, they just left it as 22,35. So it's a little bit weird. You can't really do a slight part of a push-up. Well, I guess you could, but you know what I mean. Like, I would say 23 would have been better, but yeah, they left it like that. Okay, this question says, write down the mean number of push-ups. So the push-ups is these ones over here. So they want you to calculate the average. So if you know how to do it on your calculator with a special method, you can do that. Otherwise, what we're going to do is we're just going to go add all of those numbers together and then divide by 15. It's like calculating the average. It's exactly the same. Mean and average are the same things. So they want to know what is the average out of these 15 numbers over here. And the answer that we should get is 18,3 3. This question says, the players trained hard during the season. At the end of the season, the coach reported that each player was able to do 5 more push-ups per minute than they did at the beginning of the season. How does this increase in the number of push-ups influence the standard deviation of the data? Let's quickly talk about what standard deviation means. So standard deviation, if you can just look at the word, so standard, don't worry too much about that, but the word deviation means that you are going off path. You are deviating from the path. I want us to think about the average, and the other name for that is the mean, okay? So I want you to think of the mean as like the center point of all of the numbers. And then depending on how close all of the numbers are to the mean, that'll tell us how much deviation there is. So if the numbers are very far away from the mean, they're not very close and they're all scattered all over the place, then we will say there is a high standard deviation because the numbers are going very far off the path. But if the numbers are very close to the mean, then we say that the standard deviation is very low because the numbers are not going very far away from the path or the average. Okay, so then there's less deviation. So let's say in your classroom when you guys wrote a maths test, let's say that the average was 65. Okay, so that was the average. And let's say there were 5 learners in total. So, or let's just say, I'm just going to write 5 other numbers. That's the average. And then I want to put the marks of 5 learners. Maybe the one mark was 64. Then someone else got 65. Someone got 66, 67, and then 63. Okay, that was class A. Let's say that was class A. Now in class B, their average was also 65, but their marks went like this: 31, then the other guy got 92, and then someone got 64, and then 82, and then 56. Now can you see that in this one, the marks are very close to the average. So here we would say that this is a low standard deviation because the numbers are not deviating from the mean. But then in this class, you can see that it's all over the place. 31, then 92, 64, then 82. So the numbers are a lot more spread out from the average, even though the average is still 65. If you had to go add up the average here, you would see that it's 65. But here you would say that there's a very high standard deviation. Now, let's see what would happen if every single one of these learners got 5 more %. Well, what would happen is that this would go to 69, this would go to 70, this would go to 71, this would go to 72, and this would go to 68. However, your average would also go up by 5, so that would go to 70. Can you see that it doesn't really look like the spread has changed much because all of the values went up by 5, the average also went up by 5, and so it's all going to stay fairly close. So the point is that if all of the values go up by the same amount, then the standard deviation doesn't change. Even over here, it wouldn't change. This would just go to 36, this would go to 97, this would go to 69, this would go to 87, and this would go to 61. But the average would go to 70, and so the spread is going to stay exactly the same. The deviation will stay the same, and so we will say no influence over here. Whether we're talking about maths marks or push-ups makes no difference. At the beginning of the season, the coach used the least squares regression line, which is this one over here, as the minimum target that a player needs to aim for. Determine the maximum possible increase in the number of push-ups. Okay, so this is where the coach would like them to be. So for example, if you are 30 kilograms, the coach would like you to be somewhere there, so it's on that line. A 40-year-old would have to be, a learner weighing 40 would have to be over there. Now, if for example we look at the, let's say we look at the 32 kilogram learners, you can see that the coach would like it to be on the regression line, which is there. That means that this learner is doing better than expected because his push-ups are above what the coach would expect. And this learner is really doing well because he's already up here at 25 push-ups, but he's only supposed to be on the regression line, which is at about 21 push-ups. So any people that are above the line, they are already doing better than what the coach wants. Everyone who's below the line, they need to improve a bit. Now, if you look at this person over here, that person is really needing to make a better effort because that person is 40 kilograms. They're chilling down here at 6 push-ups, but the coach would have wanted it to be on the regression line, which is there at 16. So the question says, determine the maximum possible increase in the number of push-ups, what would be 16 minus what the learner can already do, which is 6 push-ups. So they're going to have to improve by 10 push-ups. Here are all the questions we're going to do, 6 of them, but I will break them up onto individual slides. So here we have 2.1, 2, and 3, 2.4, 5, and 6. Okay, let's begin. The cumulative frequency shows the time taken in minutes for 60 employees to travel to work each morning. So the first question says estimate the median. Now we know that median, the formula is n plus 1 over 2. Now you got to be careful. What is n? N is normally the number of people or items, whatever. So we have a total of 60 employees, and we can see that over here as well. We can see that the graph stops up at 60. So that is our n. So you're going to say 60 plus 1 divided by 2, which is going to give you 30.5. So you're going to go up to the 30.5th person, which is like there. You don't have to be super accurate about it. And then you're just going to go with a ruler across, and then you would go down. Now, when you read it off, you just got to be careful. It's not going 61, 62, 63. I think they're counting in twos. So 62, 64, 66, 68, 70, 72, 74, 76, 78. Yeah, so they're counting in twos. So that's going to be 62, 64, 66. And so we're going to say 66. Now, if you get like 65, 67, yeah, they didn't really give a range in this one, but usually they are lenient. They don't expect you to always get it 100% on the dot. So yeah, 65, 66, 67, 64. I don't know if 64 would be accepted, but yeah, somewhere around 65, 66, 67. Now it says estimate the lower quartile. So that's always n plus 1 over 4. And so same thing, we're going to say 60 plus 1 over 4, which is going to give us 15,25. So 15,25 now, so you're going to go up to 15,25 over here. It's like literally just above the 15. I would pretty much just go on the 15 line and over there, and then I would go down. So that's getting to about 44 minutes. 40. And then this question says, what is the interquartile range, which is your IQR? Now we know that your IQR is always your upper quarter, which is Q3, minus your lower quarter, which is Q1. We've already worked out the lower quartile as 44, but we haven't worked out the upper quartile. To work out your upper quartile, it's always n plus 1 over 4, but then multiply by 3. So that's going to end up giving us 45,75. So we go to 45,75, which is pretty much almost 46. And you would go with a ruler about there. And then you'd go down, and I would get about 84. So I would get Q3 as 84. And then we can work out the interquartile range by saying Q3 minus what we got for Q1, which is your lower quarter, and you get 44. And if you minus those, you end up with 40. Okay, this question says the minimum and maximum are 5 and 120. And then it says on the line scale, scaled line in the answer book, which is this one over here, draw a box and whisker. So a box and whisker has 5 things. It has the minimum, it has the Q1, Q2, which is also called your median, Q3, and your max. So they gave us the minimum as 5, so you just put a little line over there. The maximum is 120, so you put a line over there. And then Q1, we already worked out earlier as 44, so that would be over there. And then we worked out our median as 66, which is over there. And then our Q3, we got that as 84, which is over there. Okay, then amongst these two in the middle, we make a box, and then we make the whisker. And so on the scale, draw a box and whisker to indicate the distribution. All right, so that's done. The company manager decides that all employees who travel for an hour or more will be allowed to work from home for part of the day. What percentage of the employees will be allowed to work from home? Okay, so an hour is 60 minutes. So if we go from 60 up to the graph, then it's not these people, because they are all... You can see they are all like under 60 minutes, but it's going to be all of these people. So when you take all of these people and you take them to the y-axis, or let me rather expand like this, you take this point at 60 and you go across, then don't say, oh, the answer is 26. Rather say it's all of these people that are above that. So if this value here is 26, and this is 60, then you're going to say 60 minus 26, which is 34 people. So as a percentage, 34 people out of 60, if you then multiply that by 100, that would give you 56,67. Employees work 8 hours in a normal working day. The manager decided on the following rule for time to work from home. An employee is allowed to work half an hour from home for each time interval of 20 minutes or part thereof above and okay. I'm reading this and I'm just like, my bro, I have no idea what they're saying. But don't worry, we're going to read it again. Employees work 8 hours in a normal working day. Okay, I understand that. The manager decided on the following rule. Okay, let's see what this decided. An employee is allowed to work half an hour from home. Okay, so half an hour from home, so 30 minutes, for each time interval of 20 minutes above an hour taken to travel to work. Okay, let me try explain because that's flipping weird. So don't worry about this part for now. So let's say you take 40 minutes to drive to work. Well, then this question doesn't apply to you because you are in this area. This rule only works for people who it takes longer to travel it takes longer than an hour to travel to work. So let's say someone takes 80 minutes to travel to work. Then it says an employee is allowed to work half an hour from home for each time interval of 20 minutes that is above 1 hour. So if 1 hour is 60 minutes, then how many extra minutes is 80 minutes? Well, that's 20 minutes extra. So they said that for each time interval of 20 minutes, you will be allowed to work 30 minutes from home. So this person would be allowed to work 30 minutes from home. Now, what if someone takes 100 minutes? Well, then, can you see that is 60 minutes plus 20 plus 20. So they are now 2 of the 20-minute intervals above. So now they get a 30-minute for this one that they're allowed to work from home and another 30-minute that they're allowed to work from home. So that person would be allowed to work from home for an hour. Now let's just do one more example. Let's say a person takes 120 minutes to work to drive to work. Then it's going to be 60 minutes, which is the 1 hour, plus another 20, plus another 20, plus another 20. So for each of these 20s, they're going to get 30 minutes that they're allowed to work from home. So that would be an hour and a half or 90 minutes that they can work from home. What if someone takes 105 minutes? Well, then they're going to be broken up into 60 minutes plus 20 minutes plus 20 minutes plus 5 minutes. So for this 20 minutes, they're going to get 30 minutes that they can work from home. For this 20 minutes, they're going to get 30 minutes that they can work from home. And they're also going to get 30 minutes that they can work from home even for this one. Because it says an employee is allowed to work half an hour from home for each interval of 20 minutes or part thereof. So this person who's at 105 minutes would get the same amount of time that they're allowed to work at home as this one over here. So this question says, on a certain day, an employee takes 110 minutes. Calculate the number of minutes that this employee will be allowed to work from home. So if you take 110 minutes, that's going to be broken up as 60 plus 20 plus 20 plus 10. So they're going to get 30 minutes for this one, 30 minutes for this one, but they're also going to get 30 minutes for that one. So that's going to be a total of 90 that they will be allowed to work from home. In the diagram below, triangle ACD has the vertices AD and C, obviously, where A is a point in the second quadrant and B lies on side DC. Okay, I hate it when they explain stuff that's... Anyways, calculate the gradient of DC. So DC, okay, so that's pretty straightforward. We've got the coordinates, so we can just use the gradient formula. Y2 minus Y1 over x2 minus x1. I'm going to use this as my point number 2. I'm going to use this as my point number 1. You can use it the other way around if you want. So we're going to say 0 minus 9 over minus 9 minus 3. If we go type that all in, we should eventually end up with negative 3 over 4. Next one says, determine the equation of DC. Okay, well, we know it's a straight line, so it's mx plus c. We already worked out its gradient is negative 3 over 4. Then to find c, you just plug in any point on that line. I'm going to plug in this point over here. So I'm going to plug in 0 as the y value and minus 9 as the x. And so you're going to end up getting 27 over 4 if you multiply these two together. And then if you take that over, you're going to end up with c equals to negative 27 over 4. And so therefore, y must be equal to negative 3 over 4x, take away 27 over 4. This question says, show that k is minus 6. Okay, so now that we have the equation of this line, which is this over here, remember, then we can just plug in the x value because it's a point on that line. As long as it's a point on that line, you can plug it into the equation. And so if x is minus 1 and then minus 27 over 4. Right, go ahead, type that all in. And we get minus 6. And then we can just say, yeah, therefore, k is minus 6 because k is the y value. Okay, so we've done that. This one says calculate the length of DC. Okay, so DC, we're going to use the distance formula like this. So I'm going to use this as coordinate 2 again, and this is coordinate 1. So you're going to end up getting minus 9 take away 3, and then 0 take away minus 9. And if we go type this, or if we go work this all out, we get 15. This question says calculate the ratio of dB over DC. So we already have the length of DC. Now they want the length of dB. So let's just go work out the length of dB so long. So dB, you would go write out the formula again. But I'm just going to go straight into it. So I'm going to use that as 0.2 and that as 0.1. So it's going to be minus 1, take away 3, which is negative 6, take away negative 9. And so if we had to work this out, we should eventually end up with... Okay, so if we then know that dB is 5 and DC is 15, if you simplify that, you end up with 1 over... If M is a point on AD, okay, so M is somewhere on AD, such that AC is parallel to MB. Okay, so if this is AC and then the other line is parallel, then you could imagine, like for example, AC is parallel to MB. Oh, okay, so MB is going to go, okay, so B is over there, so M would have to be somewhere there. So you see how these two lines are parallel, so M would have to be somewhere there. Then it says calculate the ratio of the area of MBD, so M to ACD. They want to know what is the ratio of the yellow triangle to the green triangle. Okay, so this actually goes into the section now of grade 12 Euclidean geometry, where I've taught you guys how to work out the ratio of areas of triangles. They are either going to have, when calculating area ratios, the two triangles either have a common. Now these two triangles have a common angle. Can you see that they both use the angle D? In both triangles, you've got that angle over there. You're not going to use the common height approach, okay? Definitely these two triangles cannot have the same height. You can see that the green one is much bigger than the yellow one. So how could they have the same height? So what we're going to do is we're going to use the area formula that uses an angle, which is half A times B times the sin of at the angle. So if this is the angle over here, then for the yellow triangle, just look at the yellow triangle, then it's the two sides that are next to that angle that we're going to use. So we're going to say half, and we're going to say BD times by MD times by the sin of that angle, which is D. Then for the green triangle, which is that one over there, then we're going to use the sides CD and AD, and then we're also going to use the sin of angle D. So let's cross out what we can. So we know that this cancels, and this cancels, and this cancels, and that cancels. So what we are pretty much left with now is just going to be that over there. If you look carefully, we've got DB and DC over there. And here we've also got DB and DC. It doesn't matter the order of the letters. We can change it to DB if you want. We can change that to... So we already worked out that ratio as a third. So we can actually go fill that in now as 1 over 3. And then we still need and AD. And then these have cancelled. We need to just go work out the lengths of these two parts here now. But we actually don't. I just realized. They told us that these two lengths are parallel. We can then think about basic triangle proportionality theorem. We know that if those two sides are parallel, we can then say BD over this one over... Okay, let's be strategic about this. You see how we're looking for MD? So we're looking for MD. Then we're also looking for the long side, AD. So we want the short over the long. So let's do the short over the long over here. So that's going to be BD over the long, which is CD. And then we want on the other side, we want the short over the long. And that's going to be because of, now you can either say prop theorem, and then you can say that BM is parallel to AC, or you can just say line parallel to one side. So you can either say this, or you can say prop theorem, but then you have to say which lines are parallel. If we have BD, so we already know what BD over CD was. That's this one, right? We got a third. So we can now just, we'll then realize that MD over AD is also going to be a third. So now we can actually just go fill that in over here, which is going to be a third times a third. It's going to be 1 over 9. So the answer would be 1 over 9. And look, if you didn't remember that you could use prop theorem, yes, you could have gone and used the distances, but to find the distances, you would need the coordinates of M, but that wouldn't be too difficult. Although, yeah, it would be a bit tricky actually, because we don't know the coordinates of A, so it's going to be difficult to even get this gradient, so you wouldn't get this gradient. So it would almost be, I wouldn't say impossible, there might be a way, but it would take quite a long time. This last question says, for 6 marks, if it is further given that the gradient of AD is -4. Okay, so now we have the gradient of this line as -4. So its gradient is -4. And the length of AD is 600, or the square root of 612 units. Calculate the coordinates of A. Actually pretty straightforward. We know that the coordinates of A are X and Y. So there's 2 unknowns. They've given us 2 pieces of information, so we shouldn't have a problem. We can go say that the gradient of AD is -4. So we know that the gradient of AD would use this formula. Now we know then, I'm going to call this as point number 2, and I'll call this as point number 1. And we can then just say y take away -9 over x take away 3, and we know that the answer should be -4. They've told us that. So if we then simplify, we're going to get y plus 9 over x minus 3, and that's -4. So there we have 2 unknowns, but that's okay, because now we have another piece of information. So we know that square root of 612 is going to be equal to the distance formula. Now, obviously, you would have to go write out the distance formula, but I'm just going to go straight for it now. So we're going to get x minus 3, and then y take away -9. If we square both sides, so in maths we can square both sides, get rid of the square root. So now we just end up with 612 equals to x take away 3 squared, and then y plus 9, it will become a plus 9 squared. And so now we can actually just quickly write what we have. So this minus 3, that's our one equation, and then our other equation is this over here. Now it's just going to be simultaneous. So what I'm going to do is I'm going to use cross multiplication over here, and so you're just going to end up with y plus 9 equals to minus 4x minus 3, and so you're going to end up with minus 4x plus 12, and then you're going to get minus 4x plus 12, take away 9, and so y would be minus 4x. So let's say that was equation 1, that was equation 2, this is now equation 3. Then we know how to do simultaneous. I'm now going to go substitute equation 3 into equation 2, and so we're going to get 612 equals to, now in the place of y, I'm going to replace it with minus 4x plus 3. So you see what I did? I just replaced this y with minus 4x plus, which is what I got here. Okay, and now it just becomes a case of don't put the 2's into the bracket, rather multiply the brackets out. So you'd make 2 brackets. Plus 3 plus 9 is just going to be 12, and so we can make 2 brackets. Okay, and so we end up with 612 equals, now it's going to be x squared, take away 3x, take away 3x, add 9, and then this will become 16x squared, take away 48, take away 48x, and then plus 140. Okay, and now we're just going to simplify, so I'm going to take everything to the right, so we're going to have 17x squared from these two, so we've used those now, and then for the x's you're going to have minus 3, which is minus 6, minus 48, which is minus 54, and then minus another 48. It's going to be minus 102x. And then for all the numbers, we've got 9 plus 144 minus 612, and that's minus 559. Okay, so it doesn't look very pretty, but I would definitely use the quadratic formula now. So you would normally go write out the quadratic formula for them. Well, let's actually do it. It's minus square root b squared minus 4ac. Okay, and then remember that a is the 17, b is the minus 102, and c is the minus 459. And so you would show them how you fill that all in. So the b is minus, then minus squared minus 4. Now a is 17, b is minus 4, and then a is... Okay, if you had to go solve, you're going to get two answers, and it's actually quite nice. X equals to 9, or x equals to minus 3. Who would have ever thought we would have gotten that from this nonsense? Okay, so we have the x values now. Okay, we're actually going to have to choose. Oh no, it's actually easy. They told us in the very beginning, remember the very beginning, they said that A is a point in the second quadrant. So you can't have a positive x value in the second quadrant. So you can't have 9 as an answer. So the only answer for A is going to have an x value of minus 3. So now to find the y value, we come back to this equation, we plug in that x value, and we get 15. So it's going to be x equals to minus 3, or let's say that the coordinates of A are going to be x equals to minus 3 and y would be equal to the midpoint formula, which goes like this. I'm going to take this one, and I know that I'm going to use this over here as my point 2, and I'm going to use this as my point number 1. I'm going to label it x and y. So I'm going to say x plus 3, because the x value of point number 2 is 3, and I know that the answer should be 1. I know that the x coordinate midpoint is 1. I'm going to write it as 1 over 1, and then I'm going to use cross multiplication over here, so you're eventually going to end up with x plus 3, and so x must be equal to minus 1. So this x value must be minus 1. Now we're going to do the exact same for the y value. So y1 plus y2 over 2 must be equal to y plus 9 over 2, and the answer should be 3 because of that over there. So once again, you can just cross multiply, and you would eventually end up with y plus 9 equals to 6, and then if you take that over, you're going to end up with minus 3. That's minus 3. So there we have it. This question for 4 marks: determine the equation of tangent ST. Very easy. All we do, we remember that a tangent and a diameter or a radius, whatever you want to think of it as, is always 90 degrees. So if we know the gradient of this line, then we can easily get the gradient of that line, because we know that when two lines are perpendicular or 90 degrees, then when you multiply their gradients, it always adds up to minus 1. So that means we will then have the gradient of this line, and then we can just plug in that point to get the value of C, or the, in the equation of a straight line, you've got that. I'm talking about that C over there. Now for this line over here where we have to get its gradient, whether you use the points M and P, or M and L, or P and L, it doesn't matter. It is all one line, and the gradient of a line stays constant along the line. So I'm going to use M and P. So to get the gradient of M and P, we use the gradient formula. And so I'm going to use, I'll keep that as point number 2, and I'll use this as point number 1. And so that's going to be 9 take away 3 over 3 take away 1. And that's going to give us 6 over 2, which is 3. Now that we have the gradient of this line, we can now remember that whenever two lines are perpendicular, because remember these are perpendicular, let's just go write that out. They don't expect you to show this on the memos, but just for your own knowledge, remember that we know that the gradient of MP multiplied by the gradient of, or let's first say that this angle is 90 degrees. So the angle SP is 90 degrees. Why? Because you have a tangent that is perpendicular radius. And so because those two lines are perpendicular, we can then say that the gradient of MP multiplied by the gradient of ST must be minus 1. That is just something that we know when two lines are 90 degrees to each other. So we can then go fill this in as 3 times the gradient of ST equals to negative 1. If you then get the gradient of ST alone, you're going to end up dividing by 3, and you're going to get negative a third. So now we have the gradient of the tangent. We can go fill that in as negative. Okay, so now we're busy on this line over here. So now we can plug any point on that line, which is that one over there. So we can plug in the 9 as the y, 3 as the x. You will now end up with 9 equals to negative 1 plus c, and then c is equal to 10. And so the final equation of that tangent would be y equals to negative a third x plus 10. Okay, moving on to this one. It says, show that the equation of the circle can actually be written like that. Okay, very easy. We know, just completely don't start with this. If some of you thought, hey, maybe I should start with this and then I'll complete the square. No, leave that as it is. What we're going to do is we're going to go use the circle equation formula, which is typically something like this, okay? And we're going to go full in the circle center, which is going to make that x minus 1, and then y take away 3. And then to get r, you just need to plug any point on that circle. You could go work out the distance over here if you wanted to, but you could also just plug this point in. So the x is 3, the y is 9, and then you're just going to end up with, if you had to go type this all in on the calculator, you're going to end up with 40. So 40 is equal to r squared. You don't need to go any further now. You don't need to get r by itself. Why? Because we just want the equation of the circle, which is then going to be x minus 1 squared plus y minus 3 squared equals to 40. Because we already worked out r squared as 40. And so we just leave it there. And so this is the equation of the circle. So how do we make that look like that? Easy. Just go multiply everything out. We're going to put 2 brackets and then over here as well. Okay, so we're going to end up with x squared. Now I'm going to go a little bit quicker. So minus x is going to become minus 2x. And then for these parts, it's going to be minus 3y, which is going to become minus 6y. Add 9. Now, if we put x squared plus y squared next to each other like they have, then we've got the minus 2x, and then we've got the minus 6y. The 1 plus 9 gives you 10, and then if you bring a 40 over, you're going to say 10 minus 40, which is minus 30, and then equal to 0 because we've brought everything to the left. And that's exactly what they have over there. All right, and then this question for only 2 marks, show that d is 7. That's very easy. We have a circle equation. Whether you want to plug it into this circle equation or whether you want to plug it into this part over here makes no difference. I'm just going to go into this one over here. So we know that the x value, because this is a point on the circle, so you can plug it into the circle's equation. So let me just write it out over here again. Okay, so the x is d and the y is 1. And so you're going to end up with d take away 1 squared. And then on the other side, you're going to end up with 40 minus, now this over here just gives you 4. So it's going to be 40 minus 4. So we end up with d minus 1 squared equals to 36. Now, there's multiple ways you can go from this step. If you want, you could multiply these brackets out and then take everything to one side, get a trinomial and solve for d. The other way is to realize that we can also just square root both sides, and then this side will become, and so you end up with d minus 1 because the square root gets rid of the square, and then plus or minus 6. And so we can either say d minus 1 is 6 or d minus 1 is negative 6. And so d could either be 7 or d could either be negative 5. But they did tell us that d must be positive, so it can't be negative. So we'll put a line through that one. And so therefore show that d is 7. Calculate the size of angle L. So that's this angle over here, and it's for 5 marks. Pretty straightforward what we can do, guys. Let me give you the basics of how this works. It's all got to do with angle of inclination. We already know the gradient of this line. Remember, we worked that out earlier. So that means we can work out its inclination, because as soon as you have the gradient, you can get its inclination. So our inclination is always relative to a horizontal line, so we could get this angle over here. We could look at this line, because we know this line's coordinates. We know the L, and we know the D and the 1, so we can get the gradient of this line, which would allow us to get this inclination angle, which by using vertically opposites, we could get this angle. Over here, you could either use the exterior angle of a triangle, so it would easily help you to work out angle L, or you could go use the whole angles on a straight line, and then you can work out this angle, and then you can use the sum of angles in a triangle with this one and this one, and then you would get. So let's go for it. So the first one is, we know this gradient. We know that that gradient was 3. So we can then say that tan, or shift tan, and that'll give you 71,57 degrees. Okay, so we now know this angle is 71 0.57. Then you can go work out the gradient of this line. So we can go work out the gradient of LR, and we know that the gradient formula goes like this. I'm going to use this as 0.2, and this is 0.1. And remember that D is 7. So we can then say minus 3 minus 1 over minus 1 take away 7, and that would eventually give us a half. So then we can say tan shift tan of a half, 26.57 degrees. So now we have this angle here is 26.57. So we can say that angle RVN is going to be 26.57. Then we can say that this angle, which is OVL, therefore, angle OVL would also be 26.57 because they are vertically these two over here. Okay, so now we have a situation like this. We've got this triangle that looks something like this now, where we've got this angle, and then we've got this angle on the outside, which is 71.57. We've got this angle on the inside, which is 26.57. We know that the exterior angle of a triangle is always equal to the sum of the two opposite angles, so that one plus that one. So we can then say that 71.57 is going to be equal to angle L, 26.57, and that is because of exterior angle triangle. And so if you then had to go work out angle L, you would eventually get 45. If you don't like using exterior angle of a triangle, then of course you can use the other method where you can work out angles on a straight line over here. So you would get this angle, and then you could use sum of angles in a triangle to get this one. Last question over here says PR is a tangent to the circle at R. So something like that. Okay, I've connected T to R and I've made it like so it's a tangent, and prove that PT is 90 degrees to, or PT is perpendicular to RT. So PT is there, and they want us to prove that that is perpendicular to RT, which is this one over here. They want us to show that this angle is 90 degrees. This one here, is that 90 degrees? Very straightforward. Check this out. We've just proven that this angle here is 45 degrees. Now, if you just look at this tangent over here, and remember that when you have a circle, and you have a tangent, and you have a chord, then the angle that is trapped between the chord and the tangent, so that angle there, okay, so that angle there will always be the same as any angle that chord makes, so that angle there. So here we have so here we have a tangent, right? We've got this tangent line over here. Now here's a chord. So there is the angle that is trapped between the tangent and the chord. Now where does this chord PR, where does it come together? Well, if you travel this way and you travel this way, they come together at point L. So according to the tan chord theorem, then this angle must be 45 degrees. So angle TRP is going to be 45 degrees because of the tan. And so let's just fold that in over here. Now, if you look in this triangle over here, we know that this line as well as this line are both tangents. Okay, we were told that TR is a tangent to the circle. Over here, they told us that ST is a tangent. So when you have two tangents to a circle that are coming from the same exact starting point, like if you have a circle and you have a point, you have a tangent that, and you have a tangent like that, when it comes from the same point, then we've learnt that these two lengths would be the same because of tans from common point. So we know then that the line PT is going to be the same as the line RT, and that is because they are tans. So now that we know that these two lengths are the same, well, the angles opposite those lengths will also be the same. So we can then say that the angle, this angle here, so I'm going to call that TPR is going to be 45 degrees, and that is because they are the angles that are opposite equal. It's like having an isosceles triangle. If you have an isosceles triangle with two sides that are the same, then the angles, now if we know that this is 45, well, now we can easily go work out angle T. So we could just say angle PT would then have to be 180 minus 45 of sum of angles in a triangle, and so you're going to end up with PTR equaling 90 degrees, and so therefore T must be perpendicular to RT because it's a 90 degree, and that's it. In the diagram, line OP is given with the coordinates of P and then they give us the angle KOP. Okay, first question. Determine without using a calculator the value of cos A. So all you do in these kind of questions is you literally just draw a line vertically to the x-axis. So then you've made yourself a nice triangle. And then all you do is you just look at these coordinates and you think about it carefully. If I gave you a point P over here, and I said that its coordinates were 0, 3, 0, 4, that would mean that it's 3 left on the x-axis and 4 down on the y-axis. So that means that this length over here must be 3, and this length over here must be 4. I'm just going to put a negative to remind ourselves that the coordinates are negative. If you want to work out this length over here, you would just use Pythagoras. So you could just say that OP squared. And so to get the length of OP squared, you can just say 3 squared plus 4 squared, and that's going to be 25. And then when you take the square root, you get 5. Hypotenuse, this diagonal one, that'll always be a positive on these diagrams, no matter where on the diagram you are. Right, so now we have a triangle. Now what we have is a perfect little triangle where we can go work it out. So now they say cos A. Now this is a part that confuses a lot of learners, and we could speak about this for a very long time. But when they give you this whole angle A like that, and then they ask you for cos A, just pretend you're working with this little angle here in the corner of this triangle. So remember that cos is adjacent over hypotenuse, or if you prefer using x, r, and y, then it's x over r. And so what you should end up getting is -3. You don't go say shift cos and 3 over 5. They're not asking for the angle, they just want cos A. And so this is the answer. Now, what are we going to do with cos 2a? This is where learners make a lot of mistakes. Here are some of the things that are wrong. What some learners do is they'll just say, oh, isn't cos 2a? Can't I just put the 2 in the front and then I just do that? Nope, completely wrong. Instead, what you're going to do is remember that 2a is double a. So, therefore, you're going to need double angle formulas. And so from your formula sheet, for cos 2a, we've got 3 different options. You could use cos squared a minus sin squared a. You could use 2 cos squared a minus 1, or you could use 1 minus 2 sin squared a. You can choose whichever one you like. I'm going to go with this one over here because we already have cos a. And here we also have, it's got a square, but that's okay. So we know that this can be rewritten as 2 minus 1. So you see how we now have a cos A. And we already know what cos A is. It's -3 over 5. All that we do now is we just say 2 in brackets, -3 over 5. We square it because of that square. And then we say minus 1. And you can just literally go type that on the calculator. It's only worth 2 marks. And so that's going to eventually give us -7 over... Now, if you had rather wanted to use this one or this one, it's perfectly allowed. All that it would mean is that you would have to have gone and worked out sin A from your triangle first. But that's very easy to do. You just use y over r or opposite over hypotenuse, whichever one you prefer. Okay, and then this question says... determine the value of sin A minus B if it is further given that sin B is 4 over 5. Okay, very good question. So from our formula sheets, we can see that we have, we've got these compound angles. Now they've given us a sin A minus B, so that is this one over here. So if we're to go expand sin A minus B, if we just follow the formula, it's going to give us sin A cos B minus cos A. So what that means is that we are going to have to go get sin A, which we can get from this triangle because this is the angle A triangle. And we're going to then need cos B. We don't have cos B. We don't even have a triangle that has the angle B. So we're going to have to make a brand new triangle. Cos A, we already have over here. And then sin B, they've given us. Okay, so the only unknown, or the thing that we're really going to have to try hard to get, is cos B. But that's okay. So we're going to take this information here to make a brand new triangle. So how do we know which quadrant to draw the triangle? Well, from these 2 pieces of information, we will be able to figure it out. We know that this is 0 degrees. This is 90, 180, 270, and then back to 360. They tell us that the triangle or the angle is somewhere between 90 and 360. So it could either be here, here, or here. The next thing they tell us is that sin is 4 over 5. But all I want you to see here is, are they saying that sin is positive or negative? It's a positive number. So where is sin positive? Well, where is sin positive on this whole diagram? Well, we know that all of them, sin, cos, and tan, are positive in this quadrant, because we always call that the A quadrant on the quadrant diagram. Sin is also positive in here. Remember, it always goes A, S, T, and C. So we know that sin is always positive here. So can we then see that this is the correct quadrant, because it was perfect for this part and it was also perfect for this part? And whereas all of the others, you can see that they only have one tick. They don't satisfy both conditions. So we are going to draw our triangle in this quadrant. So how do you draw it? Well, you always start at the origin and you always go diagonally. Then am I going to go right or am I going to go down? You're always going to go to the x-axis. There we go. Okay. Now, and then you would label it like this. That would be, so they said that sin is 4 over 5, but we know that sin is y over r, if you rather prefer opposite over hypotenuse. So you got to now think of this as your angle, and so the opposite must be 4 and the hypotenuse must be 5. Then if you had to go use Pythagoras, you would end up getting a 3 for this one, but then I'm going to put a little negative in front of that 3 because it's on the negative x-axis. This one's going to stay positive because it's on the positive y-axis, and then this one will always be positive. Remember, the hypotenuse is always positive. Okay, now we can go work out cos b, because we know that cos is adjacent over hypotenuse, or x over r, whatever method you prefer, and that's going to give you negative 3 over 5 from this triangle here. So we have this, oh no, we still need to go work out sin a. Sin a, now I've got to work on the a triangle. I know that sin is opposite over hypotenuse, or y over r, and that's going to give you negative 4. So now we have this, we have this, we have that, and we have that. We're good to go. So we're just going to go sin a minus b, and that's going to be sin a, which is negative 4 over 5, cos b, which is negative 3 over 5. Then we're going to say minus, and then cos a, we already have it as negative 3 over 5, and then sin b, oh, they gave us that one as 4 over 5, and so that's going to end up giving us 12 over 25 minus, and then this is going to be negative 12 over 25. And so these are going to end up adding together. So I'm just going to turn that into a plus. And so you're getting 24 over 25. If cos alpha is equal to p, express the following expression in terms of p. Right, so I think what I would do is I would see this whole thing as a cos a minus b. So I would go to this one over here, and so that's going to end up becoming, okay, so we're still going to have this 2 at the bottom. So I'm going to write it as cos alpha over 2 cos 45. So I'm copying this, right? Then it says there's a plus, and then it's going to go sin alpha over 2 and then sin 45. So that over there is just that part over there. And then I'm going to expand the next one, this 2 over here. I'm going to expand this one using this expression over here. And so that's going to become alpha over 2 times by the cos of 45, alpha over 2 times by the sin of cos 45 and sin 45. That is always going to give us, okay, it depends if you use your calculator or if you use special triangles, but nowadays special angles are not being used as often, and they're just allowing you to go straight to the calculator. So you're just going to get square root 2 over 2 for both of those. Cos 45 and sin 45 are just square root 2 over 2. So I'm going to go replace all of these now with that. So that's going to become cos alpha over 2 times by square root 2 over 2 plus sin. So you get the idea, right? I'm just replacing the sin 45s and cos 45s with square root 2 over 2. Next thing I'm going to do is I'm just going to put the square root 2 over 2's in the front for all of those. And then the next thing we're going to do is just FOIL this all out. Okay, so at the bottom we're still going to have a 2. So I'm going to start off by multiplying these two together. So you can just type the square root 2 over 2 on your calculator, and so you can multiply this square root 2 over 2 with this square root 2 over 2. And you'll notice that that's just going to actually give you a half. We're going to end up with a half cos alpha over 2 sin alpha over 2. Then what you would notice is that if you multiply these two together, that's going to give you negative a half cos squared, negative a half alpha over 2. And then I'm going to multiply these two together, which is going to give you a half of alpha over 2. And then lastly, minus, and then it's going to be a half sin alpha over 2 cos alpha over 2. And so what you'll see is that these two expressions are exactly the same. Yes, the sin and cos are switched placing. Oh, that was a terrible English. Switch placing. It's like having xy or yx. It doesn't matter. It's the same thing. So those are going to cancel out. Oh, and then at the bottom we still have this divide by 2. Okay. So those are going to cancel. Boom and boom. So all that we're going to have left is at the top. I'm going to put this one first. So half sin squared alpha over 2 minus half cos squared alpha over 2, and that is all over. Now the next thing I see is that sin squared minus cos squared is almost the same as that. It's just the reverse of that. That's what I'm going to try aim for. So the first thing I'm going to do now is take out a half as a common factor. So that's going to end up giving, you take out a half, and then what you'll be left with is sin squared alpha over 2, alpha over 2, and then all of that is over 2. So then you can type these two numbers on your calculator, a half divided by 2, and it's just going to give you a quarter. So then we're just going to have a quarter, sin squared alpha over 2 minus, and then, sorry, I'm just running out of space over here. So the next thing we're going to do is we're going to take out a negative as a common factor, so that we're now going to cause this expression to become a positive and this expression to become a negative. So we're going to end up getting something like, I'm going to put the cos in the front, cos squared alpha over 2 minus sin squared alpha over 2. These two expressions, this one and this one, are exactly the same thing. I'll prove it to you. If you had to multiply this negative back inside here, you would have a negative for the cos, which is what we had here. And if you had to multiply this negative into here, you would have a positive for the sin, and that's exactly what we had. So this and this, they are exactly the same thing, but now this one is just a lot better to work with because now it looks exactly like that. So let's have a look carefully. Whenever we have the cos squared minus the sin squared, just like we have here, then what you can do is you can rewrite it. But now look carefully. Here we have alpha, here we have 2 alpha. So what we are doing when we go from this to that is we double the angle. So we're going to say cos, and then we're going to double this angle. Now, if you double alpha over 2, then it's going to end up becoming, if you double that, so alpha over 2, and then if you multiply that by 2, the 2's cancel, and you actually just get alpha. So we just end up with that. And we know that cos alpha is equal to p. What we're now going to do is just replace cos alpha with p, and so we get a final answer of negative a quarter. Given the identity, this is an identity that we already know about, use the compound angle identity to derive a formula for this one. So this is almost like a proof, or it is a proof, where we have to take this and then try work out something for that. So all we do is we just say, okay, the thing we're trying to work out is cos x plus y. But we don't know what to do when it's a plus in the middle. They've only given us a formula for the minus. I know you know that on your formula sheet you could find something, but that defeats the purpose of the question. You got to pretend like this is the only thing that we know, and we got to try work out this. All we do is we just rewrite this as cos minus y. Because isn't this still plus? So aren't these two expressions still the same? Yes, but now we've written it in a special way that looks like this now. So can you see that this is going to be your first angle and this is going to be your second angle now? And so now you're just going to copy this. So it says cos of the first angle, and then cos of our second angle, which is now negative y, and then sin of our first angle, and then sin of our second angle, which is now negative y. And so that just becomes cos x. Now, what is cos negative y? If I ever gave you, like on the cast diagram, and I said, what is cos negative 20, for example? Well, what we've learned is that you don't want to work with a negative angle, so you would add 360. So I'm going to do the exact same over here. I'm going to add 360, and I'm going to do the same exact thing with this negative y. And so I can then rewrite that as cos 360 minus y, and then sin of 360. Now we know that from the cast diagram, cos 360 minus, it just becomes the positive of that angle, right? Like if you had cos, if I said what is cos 360 minus x, you would just write that as cos x. Because on the cast diagram, we have a 360 minus x, and that's always where cos is positive. So moving on, what does the sin of 360 minus become? Well, that actually becomes a negative. So I'm going to put a negative sin. So the only thing we now need to do is just do this, and then we're going to put this negative and this positive. So if this whole expression is negative, right? I could almost just the negative in the front like that. But then this positive and that negative make a negative. And then there you end up with that. So there we've ended up with our final answer, which is going to be cos x, cos y, minus sin x. Now this question says hence or otherwise show the following for 6 marks. Okay, so I'm going to ignore this for now. I want to go simplify all of this as much as I can. So the first thing I know is that this is a co-function. You know, we have 4 of those. We have cos 90 minus x becomes sin x. And then we've got those 3 others. So we're just going to change this to sin x. We're going to leave that one as cos y. And then sin of negative y. Now, it does become negative sin y, but not because we're taking a negative out of a common factor, but rather because of what I showed you earlier over when we were busy doing that question. We had sin negative y. So we changed it to, we added 360. So we said negative y plus 360, which is then the same as 360 minus y. And we know that that is in the 4th quadrant where sin is negative. So we say negative sin y. So let's just say plus, because that plus is already there. Then we're changing that one to negative sin y. And then cos 180 minus x, we know that that becomes negative cos x because that's in quadrant 3. Now, these 2 negatives, they're just going to make a positive. So I'm just going to ignore that and that. And then we can just have it like that over there. Then at the bottom, we're just going to leave that cos x as it is. 360 plus y. So when you have 360 plus y, I'm just going to minus 360. You're always allowed to add or minus 360. And so that actually just becomes cos y. So we're just going to write that as cos y. And then sin 360 minus x, we know that that becomes negative sin x because that's in quadrant 4, and then sin y. Now these 2 will just make a negative, and there we have it. Okay, now I'm not even going to look at this over here. We don't need that because they said hence or otherwise, so you don't have to use this previous stuff. Let's go get our formula sheet now, and let's go find an expression that looks like this. So it's a sin cos. So that would be, it doesn't matter if the cos and sin are switched around. We can easily just switch that around because when you are multiplying, order doesn't matter at all. So we can do that. And then here we have a cos minus sin. So cos minus sin. So that's this one over here. Okay. So the top one is going to be rewritten as this. So that's going to become sin x plus y. And then the bottom one is going to be written as this, which is cos x plus y. Now when you have sin over cos and the angles are exactly the same, then it just becomes the tan of that angle. Here we go. What some learners do, they think, oh, sin x minus y over cos x, that'll just become tan. But no, these angles have to be exactly the same. And what some learners also do is they think that you cancel these out and then you're just left with sin over cos, which is tan. Then tan of what? Tan of nothing. So you can't cancel the angles out. Remember that these angles, they are a part of the sin and they are a part of the cos. You cannot just remove the angles. So there we've done it. We've gone and shown that this side is equal to that side. And so we could just say here, therefore left hand side is the same as the right hand side. We could have actually just said here left hand side when we started working on this one. Sure, imagine being a student and you see a square root with trigonometric things inside. Looks a bit weird, right? But trust me, we're just going to go do little pieces at a time and you're going to see it's going to all work out. Okay, so solve for x in the interval if f of x is equal to 2. This will come in a little bit later, this part here. Okay, so don't worry about that right now. Immediately, I see that that is a co-function, and I know that that is the weird co-function, which actually becomes negative. So I'm going to immediately go and fill that in. 6 sin squared minus 11 multiplied by negative sin x plus 7, which is then going to become 6 sin squared x plus, because that negative and that negative make a positive. Don't even look at the square root. What do you see on the inside? I see a trinomial. So I'm going to go and factorize that trinomial. And don't really want to use the quadratic formula here. Yes, there are ways you can use the quadratic formula to help you factorize, but I'm not trying to solve for x right now. I'm trying to make two brackets. So let's see what if we can come up with something. So you can just think of it as 6x squared plus 11x. So let's play around with this and see what we can do. I have started showing learners a faster way to factorize these kind of ones where the number in the front is not a 1. All you do is you multiply these two numbers together, so that'll give us 42. So you're going to say x squared plus 11x plus 42. Then you're going to factorize this as normal. So 42 is the same as a few different things we could say there. 1 times 42, 2 times 21, 3 times 14. There we go. Although I don't think that one's not actually going to work. What else? 6 times 7. Okay, so it doesn't actually factorize. I thought it was just going to factorize. I thought it was just going to become I thought we were eventually going to end up with two brackets that are the same to the power of 2. But instead, let's go back a step. Let's now fill in the f of x equals to 2. Now we can square both sides. So square and square. We end up with 4 on the left. Square root disappears on the right. Okay, now we're going to retry the trinomial thing. This time it's probably going to work because we're going to bring that 4 over. It's going to become plus 3. Okay, let's try again. So once again, if we have a trinomial, you can think of it as 6x squared plus 11x plus 3. This is a new method I've started showing learners when this number in the front is not a 1. So you multiply it over there. That's plus 18. We know that 18 is the same as 2 times 9, and 2 and 9 do make 11. So this now factorizes perfectly as x plus 2, x plus 9. Now, remember in the beginning we multiplied with the 6. Now we're going to divide with the 6 over there and over there. And so that becomes x plus 1 over 3 and x plus 3 over 2, if you had to just type those on your calculator. What you then do is, if you have a fraction over here, which we do, you take this number and you put it there, so that becomes 3x plus 1, and then you take this number and you put it there, so that becomes 2x. And so there you factorized it, but obviously we don't have that. We actually have sin x and 2 sin x, and so we can just go fill this in now, and 2 sin x. Okay, so now we can say, therefore, 3 sin x plus 1 is 0, or 2 sin x plus 3. And so if you say 3 sin x plus 1 equals to 0, take the 1 to the other side, divide both sides by 3, and you end up with that. And then for the other one, you have 2 sin x equals 0, take the 3 to the other side, divide both sides by, and you end up with that. Now it's just going to become general solutions. So you know when you're going to go get the reference angle now? So to get the reference angle, you're going to say shift sin on your calculator, and then you're not going to put the negative on the calculator. That negative 1 is just the symbol that it shows on the calculator, and you're going to put 1 over 3. That's going to end up giving you a reference angle of, now we're just doing general solutions, okay? 19,47. And so then what you do is you go work in the quadrants where sin is. That's going to be quadrant and quadrant. So in quadrant 3, we say x equals to 180 plus the reference angle plus k times 360. K is an element of z. And if you had to solve that, you're going to get 199.47 plus k 360, k element z. But this is actually going to be a specific solution. Okay, so I will take that into account now. And then for the fourth quadrant, you would say x equals to 360 minus the reference angle plus k 360, k element z. And that's going to end up giving 340.53 plus k 360, k element z. Okay, but now because it's a we have an interval here 0 to 360, it's a specific solution kind of question. So if I make k 0, then I get 199.47, and that is actually the only answer for this one, because if you make k anything else, then it's going to end up causing the answer to go outside of that. Okay, and then for this one as well, the only answer is going to be 350.53, because if k was anything else, like 1 or minus 1, it's going to cause the answer to go outside of that. So the two answers are those over there. Consider the function g of x equals to that. Calculate the maximum value of g. Okay, grade 12s, it's got nothing to do with calculus. The way you handle these kind of questions is the following. So I'm just going to go write out this expression nice and big. If you want to make this expression as big as possible, what do we want the top to be, the numerator? Do we want it to be a large number or a small number? Well, we want this to be as large as possible. So let's just write that down. We want the numerator, and you would want the denominator to be as small as possible. But there's nothing we can do with the denominator. It's a 3. You can't change anything about that. But okay, so this part we can change. We can have a look at that part. But let's just talk about the following. This is already a 4. Now we're going to minus. So because we're minusing, do we want this expression to be a really big number or a really small number? We actually want this to be really small, because then you're going to be minusing a very small number. So it's going to keep this part as big as possible, right? Example, if you have 4 minus 2, then you're going to end up getting a 2 at the top. If you have 4 minus 1, well, then you're going to end up getting a 3 at the top. So the smaller you can make this part, the bigger you're going to keep your denominator, right? Because you're just taking away a smaller part. So what we need to understand, though, is that this part here is squared. So that this part here can never be negative. So the smallest that you could ever make a square is a 0, right? Because a square always becomes positive. So the best we could ever do here is get this to become a 0. So we could say let's just say we sin squared x as small as possible, so that 4 minus 8 over 3. So therefore, we're going to let sin squared x be a 0. Because a sin graph, look at a normal sin graph, does it ever reach 0? Absolutely, quite a few times. So if we could make sin x equal to 0, or let's just say, if we could make sin x equal to 0, then sin squared x would also be a 0. So then we're going to end up getting 4 minus 8 times 0 over 3, which is just going to end up becoming 4. Now, this question says, write down the smallest value of x so that g will have a maximum value. Okay, well, we already said that the graph of sin, they only want it over the interval 0 to 360. Okay, so that's going to be just a normal sin graph. They said from 0 up to 360. 360 is included, but the 0 is not included. So what is the smallest x value so that this expression will have a maximum? Well, we said that for this expression to have a maximum, we said that sin x must be 0. So sin x is 0 there, but you're not allowed to include, so this would obviously be the smallest x value that you would ever get, which is just 0, but we're not allowed to use that because they said 0 is not included. You see that, it's a round bracket. So the next smallest x value would be this one. And if you know your sin graphs very well, that's 180 degrees. So you're just going to say 180 degrees. In the diagram below, the graph of tan x is drawn from minus 180 up to 180. Write down the equation of the asymptote in the interval from 0 to 180. So from 0 to 180, there is only one asymptote. So that is the x equals 90 asymptote. Do you sometimes want to say why? Well, think about it. Listen, this point over here, is that an x value or a y value? It's an x value. So it cuts the x-axis at 90 degrees. So we say x equals 90. Okay, this one says write down the values in the interval from minus 180 up to 0, for which the graph is that. Okay, so let's just examine carefully what that means. So that means smaller, or actually let's say below the x-axis, touching the x-axis. I'll explain now. So if it just said smaller than 0, then that means below the x-axis. Because they've also said equal to 0, it means it can also touch the x-axis. So if we look over that interval from there to there, is there anywhere where the graph is below the x-axis? Well, yes, all of that. And then is there any place where it's touching the x-axis? Well, yes, over here. And also, okay, so the first part we can give is this part over here. So the way that you would answer that is you would say that x, I'll show interval and set builder notation. You would say that x is bigger than minus 90, but smaller than or equal to 0. Let me explain. So we're going from minus 90, which is this part here, all the way to 0. But we don't include the minus 90 because that is an asymptote. And you never include the asymptote because the graph never touches the asymptote. Okay? So that takes care of this part. We just need to literally take care of that single little point over there. And that part over there is minus 180. Okay, now if you want to use interval notation, you're going to go from minus 90 up to 0. The minus 90 is not included, but the 0 is included. And then you could also just say minus 180. Okay, this question says, given the equation g of x, which is cos 2x plus 1, write down the period. Okay, so if we think about a typical sin or cos graph, it comes in this format over here. Now, the period is only affected by that number. The period, and for sin it's exactly the same. So for sin and cos, the period is normally, then to work out the actual period, you're going to take that 360 and you're going to divide it by k. So we can see that the k value here, which is the one in front of the x, is a 2. So we're going to say 360 divide by 2, which is 180. If it was a tan graph, then all that changes is it's normally 180. So you would say 180 for k if it was a tan graph. On the grid, draw the graph of that over the interval minus 180 to 180. Very easy. You should all get full marks for this. Why? Because we're just going to use the calculator, and you're allowed to. So what you're going to do, you're going to take out your calculator, you're going to put it into the table mode, and it's going to say f of x equals, just type in the equation of that they've given us for g. Doesn't matter if it says g over here, but on your calculator it says f. That really doesn't matter. That's just a letter. So just press cos, and then you're going to have to press 2, then press alpha, and then x. You'll find on your calculator it's like a red x if you're using a Casio, and then plus 1. So on your calculator it should say this at the moment. It should say exactly this. Okay? Press equals. If it then says g of x, just skip that. We've already got our graph. Now it says start. Where do we want to start? We want to start at minus 180. Where do we want to end? At 180. And what do we want the step to be? Well, the step is always going to be your period divided by 4. So if we already know that the period was 180, we're going to say 180 over 4 is 45. So you're going to make your step. There we go. Now you should have all of your values. So, and that period divided by 4, that is like a fixed thing that you can always use. Okay, you should now have values of minus 180, minus 135. Okay, and so these are the coordinates that you would get. So now we're going to go fill everything in. So let's just get rid of all of that. Okay, so minus 180 and 2. So that's going to be over there. Minus 135. Minus 135 is in between here, but it's and 1, so it's going to be there. And then minus 90 and 0. So that's there. You are allowed to put a dot on the asymptote because this asymptote is only for the tan graph. And then minus 45, which would be in between here, and 1. So that's there. And then 0 and 2, 45 and 1, 90 and 0, 135 and 1, and then 180 and 2. And then you're going to draw through that. Okay. Now they say clearly show the intercepts with the axes. Okay. So that's going to be 90 and 0. This is going to be 0 and 2, minus 90 and 0, as well as the coordinates of the turning points. Okay, so we already have that turning point. We already have that turning point. We have that one. And then technically this would have been another turning point if it carried on. So let's just label that to be safe. That's not 0. Okay, if it's 2. And then let's label this one as 180. Okay, so we've got all that. Now, this next question, I'm glad they asked this so I can show you guys something very important. They say use the graph to determine this. Now, how the heck do we take a tan graph, this equation, and then we use that to solve that? They're not even the same graphs. So like, what do we do? Well, what we do is we take this expression and we begin to work on this expression and manipulate it and do whatever we can so that eventually we probably will end up with something that is going to have, it's going to be a little bit closer to what we have. Because at the moment, we're not even close. So the first thing I'm going to do is I'm going to take the sin x to the other side. I'm then going to divide both sides by a cos x, because then I end up with 2 cos squared x equals 2. So now I've got tan. If we look at our double angle formulas on the formula sheet, we have this part over here. That is what we have at the moment over there. So what we can do is we can say cos 2x equals to 2 cos squared x minus 1. Okay, I just replaced the alphas with x's. Now we have that part. So we can now take the 1 over and you end up with cos 2x plus 1. Oh, look at that. So we can replace this with cos 2x plus 1 equals to tan x. Now all of a sudden this silly nonsense down here is actually the same as saying where is this graph, which is the one we drew, equal to the tan graph. So where do they intercept? So they intercept over there. They intercept over, whoops, not there, Kev. Over there. And okay, that's about it. Okay, but now they want it to be the general solution. So we know that this part over here, now obviously it depends on how well you drew your graph, but we know that this here is at 1, and we know that a tan graph always reaches 1 at 45 degrees. And then this one here is at tan of -1. I just didn't draw it nicely, but more like there. Okay, so this is exactly in between, so it's -135. They don't want the specific solution, so they don't want you to say x equals to 45 or x equals to -135. No, that would be the specific or the exact solution. They don't want that. They want the general solution. So the way you do that is you're just going to give the first or the smallest value, x value, that is positive. That always works nicely. So you just say 45 plus k. Now, how far apart are these? How far apart are those solutions? Are they 360 degrees or 180? To go from 45 to -135, or to go from -135 to 45, it's 180 degrees. So you're just going to say that it's going to repeat every 180 degrees, and there is your general solution. What that means is that if we had to keep drawing these graphs on and on and on and on, and we had the tan graph going as well, you would see that they would be cutting each other every 180 degrees in that direction, and also if we had to go to the right. So yeah, end of story. That is the, or to cut a long story short, that's what I meant to say. That is your answer over there. In the diagram, C is the foot of a vertical building. It's nice that they're actually putting the building in the background, because learners often struggle to visualize. That's quite nice. Very sweet and kind. I actually want to start crying. Okay, I'm fine. I'm composed. Okay. Vertical building at D is the top of the same building. The height of the building is 16 meters. There we can see. Two observers are standing 19 meters apart. Or they could have drawn the flippin' observers. They just get it right for once, man. Yo. I'm joking, guys. At point A and B, where A, B, and C lie in the same horizontal plane, what that means is that this is all on the ground. That's what they mean when it's the same horizontal plane. It's all on the floor. Okay, so you can imagine all the cars are parked here. A painter is working at point E. Okay, so he's obviously standing on a ladder, something like that. The angle of elevation of D from A is 46.85. So there it is. They gave us that angle as 122. And they gave us this angle as 105.61. Fantastic. That's really nice that they have a drawing there. It's the first time I've seen that. Calculate the length of AC. And that's for 2 marks. AC. So that you can actually work in this triangle here. It's using grade 10 trigonometry because it's a 90-degree triangle. So we can just use our normal SOHCAHTOA. No need to use any fancy A squared, B squared, C squared, 2b, cos, you know, all those weird like sin A over A equals sin B over B. You don't have to use that right now because we have that triangle, and we're looking, if I draw that triangle from the side, it looks like this, where this is D, this is C, this is A, and this is 46.85, this is 16, and they're looking for this. So we can just see that this is the opposite, this is the adjacent, so we're going to use tan. So we can say tan 46.85 equals to the opposite over the adjacent. And then to solve this, you can imagine it as tan 46.85 over 1. And then if you just do cross multiplication, you end up with that over there. And then if you get AC alone, and if we round off, it's a really nice answer, 15. So let's just say 15 meters just to be safe. They'll never really mark you down if you don't add the units or whatever, but yeah. Okay, now for this one, 7 marks. Have you ever thought about the word marks? Well, I've got a in a state that I live in. Okay, that was a joke. If you know what I was about to get to, then you know. There's this video that I made once upon a time where I go on about, imagine if your name is Mark, and so many learners made TikTok and Instagram videos about that. And you thought I was about to go through all of that again. No, I'm not going to do that. I've matured now, guys. Calculate how far the painter at E is from the top of the building. Okay, so they pretty much want us to calculate E from the top of the building. So they want us to calculate this length. So we know that that is 16, which is this whole piece. So pretty much, if we could work out this length over here, then let's say this is 5, then you could just say 16 minus 5, and that would give you that piece. I guess that's the way we're going to go. So we're going to eventually need to work, which means that we're going to work in this triangle eventually. So we need as much info as we can in that triangle. So the first piece of info is that we have a straight line. So we could work out this angle. So we could call that angle BC. BEC is this angle here. That's going to be equal to 180 minus 122, and that's just because of angles, straight line, and that's going to be 58 degrees. Okay, so we now have that as 58. So the next thing, we're probably going to have to work in this triangle over here, and we know AC is 15. So we're probably going to work in this triangle now, something in this triangle. So what do you think we're going to get? Well, yes, we're going to get BC, because once we have BC, then we've got quite a lot of information in this triangle, and then we're good to go. So does that make sense? Once again, we're going to work in this triangle now, and that's eventually going to allow us to get BC. Once we have BC, we can then work in this triangle because it's a 90-degree triangle. You see the 90 over there? And that'll allow us to work out this length, and then we're good to go. So, in this triangle, it's not a 90-degree. So we're not going to use our SOHCAHTOA from grade 10. Now we're going to have to go down to the grade 11 formulas like sin A over A equals to sin B over B, or C squared equals to A squared plus B squared minus 2AB cos C, whatever. So it's these formulas here. Now, what I always tell learners, I don't try to memorize when to use this one and when to use this one. No, I just try start with this one. Okay? So I look at opposites. So I know that there's an opposite, an angle opposite a side, and then the only other thing we have is that. So if we did use this formula, then the only opposites, like I said, would be you've got that, and then you've got this length here, which is opposite that angle. So it would help you to find that angle. Okay, so that could help us. Definitely is a way. Now let's see if this one would work. So the way that one works is you've got some angle. Okay, so let's say there's our angle. Boom. Then these two, then this side over here is the side that is opposite the angle, which we do have. It's the 19, okay? Then these two sides, the B and C, are the sides next to the angle. So we've got the 15, so we could put that over there, for example, and over there. And then the only unknown is going to be C, which would then be the other side, which would be that one over there. So this is actually going to be the perfect formula to use. Let's fill everything in and it'll make more sense. So we know that we're going to say 19 because that is always the side opposite the angle. And the B and the C are the two sides next to the angle. So it's going to be the 15, so 15, and then this side over here, which we're going to call BC. Then we're going to say 15 again and BC again, and then cos of the angle, which is 105.61. So the only unknown is going to be the BC. So this looks interesting. It's going to be a trinomial. I've never seen a trinomial, but don't panic. A lot of you right now, you're like, oh my god, a trinomial in trigonometry, like with 2D and 3D trig. Guys, it's going to be super easy. Let's quickly calculate that. 361, 15 squared is 225, and then BC squared, and then this is just going to give, I'm going to type that all on the calculator, so negative 8.0726. I don't want to round off just yet. Okay, now those two are going to become a plus. I'm just going to change it to a plus along. And there we go. Look how scary that trinomial is. That's a joke. Guys, this is so easy. So you just take everything to the one side, and then you're going to have 225 minus 361. So it's going to become, and then 225 minus, that's going to be minus 136. And then I'm just going to use the quadratic formula. So BC will be equal to negative B plus minus B squared minus 4AC over 2A. So we know that this would be our A value, the number in the front, this would be our B value, and this would be our C value. And so when we go fill that in, they want to see you fill this in, okay? So it's going to be minus 8.0726 plus minus 8.0726 squared minus 4, and then all of that over 2. Okay, so if we go solve this now, we're going to end up with BC as 8.3, a negative number, which obviously it can't be a negative number. Can't be a negative number. So because it's a length. So BC is going to be 8.3 meters. Okay. Now we're going to have a triangle, which is now this triangle here, and that's going to be B, and this length is 8.3, this angle is 58, and so now we can just use SOHCAHTOA. If you want to go work out this angle, you can. You don't have to though. I'm just going to use this angle. So I know that I've got the opposite, and I'm looking for the adjacent. That's going to be tan. I can say tan 58 equals to the opposite over the adjacent. Then I'm going to use cross multiplication, and I'm going to end up with EC tan 58 equals to 8.3. And then I'm going to get EC equals to 8.3 over tan 58. And so that's going to end up, that's going to give us 5.186 meters. I'm not going to round off just yet. Now we have that as 5.186. And then you're just going to, say 16, because remember, this whole length is 16. We've just worked out this piece and we're trying to get this. We can then say 16 minus 5.86, and that's going to give 10.81 meters. In the diagram, ABCD is a cyclic quadrilateral. BC is produced to E. A1 is a half B. Oh, we're getting fancy, are we? A1 is a half of B. Okay, so let's remember that for later on, guys. A1 is a half of B. Let's not forget that. A2 is 46 and C1 is 86. Imagine all of our diagrams look this simple. Calculate with the reason the value of A1. Okay, so here we have a cyclic quadrilateral. Now we know that the exterior angle of the cyclic quad is going to be equal to the interior opposite angle. So that's this whole angle. So the whole of angle A is going to be 86 because of exterior angle. So then we can say that A1 plus A2 must be 86. So then A1 would have to be 86 minus 46, which would be 40 degrees. So A1 is 40. Okay, so we got that. Now, remember that if this is 40, they told us that A1 is half of B. So that means B must be 80. Prove that AD is equal to DC. So AD is equal to DC. What they actually mean by that, prove that these two angles are equal. Why? Well, if those two angles are equal, then inside this triangle here, if these two angles are, if this is 40 and this is 40, then we could say that these two sides are the same because of angles opposite, or sides opposite equal angles. We got to try show that that is 40 degrees. So that's pretty straightforward. In this triangle here, we could easily work out angle C3. So angle C3 plus 80 plus 46 must be 180. And that is because they are the sum of angles in. And so if you had to work out C3, you should eventually get 54 degrees. So this is, now over here we have a straight line. So all three of those angles must add up to 180. So we could say that angle C1 plus angle C2 plus angle C3 must be 180 because they are the sum angles on a straight. And so if you fill that in, 86 plus 50, and then if you had to work out C2, you would eventually get, and so if we get that as 40, then these two are the same, which means that the sides opposite must also be the same. So that means that AD must be the same as DC because they are the sides opposite equal angles. Don't say angles opposite equal sides. That's only if you already know that the sides are the same. Then you can say that the angles are the same because then they are the angles that are opposite equal sides. But in this scenario, we have the angles that are the same, which then means that the sides are the same. Why? Because they are the sides opposite equal angles. So you got to know when to go the one way, when to go the other way. So here in this question, we have a proof. The way that this proof works is the following. You want to eventually try prove that RA over AS is the same as RB over BT. So what we're going to start off with is we're going to start off with this triangle because that'll give us RA. Now we need a triangle that gives us AS. So what we do is we make a triangle by constructing a line that goes like that, because then we're going to be able to work with that triangle, and that gives us AS because we want RA and AS. So let's just say here, construct SB. So that is what we have constructed so far. We are going to do another construction a little bit later. And now what we're going to go do is we're just going to go work out what is the area of the top triangle divided by the green triangle, which is SAB. What we need to understand is that both of these triangles are starting on the same baseline. Can you see that they both come from this baseline over here? So and then they both meeting up here at the same point over here. So you could almost imagine us rotating these triangles around so that this part, well, however you need to, but you should be able to realize that these two triangles are going to have the exact same height. I'll try rotate it for you. Hold on. Have a look here. Here we can see that both of the triangles have the same, they both come from the same base height. And I'm going to draw a line going through here at the top as well. So can we agree that that vertical distance for the red one is exactly the same as for the green one? Because the green one also goes up to there. So if you look at the height of the green one, it's also going to be the same. But they both going in between this purple line and that purple line. And so the actual vertical height of those two triangles is the same. It's going to be the distance between those two parallel lines. That is what the height of those two triangles will be. So they're going to have the same height. And that height is going to be from the place where they meet, which is at B. And then you're going to go perpendicular to the baseline. So perpendicular means you're going to hit it at 90 degrees. Let's call that H1. So we've constructed SB and H1. And so if we then had to go work out area of the top triangle using a half base times height, well, its base is AR and then its height is H1. Now, the green triangle, its base is AS, but its height is also going to be H1. Remember that with this green triangle, which is, you could imagine, for example, it's something like that over there, or more like, I don't know, even if you have a triangle that's like that. This is B, this is S, this is A. To find the height of a triangle, you go from the top corner and you just go perpendicularly down. Even though this is not inside the triangle, that is still its height. Okay? So this height is still the height of the green triangle, even though it's not inside the triangle. So what we now see is that these can cancel and these can cancel. And so what we end up with is AR over AS, which is what we want for the first part. Now we move on to part 2, where we're now going to try get this part over here. So we get rid of all of these triangles that we've just done. And now we're going to try get this side. So we're going to use this triangle. And I'm going to get rid of all of this now. Now we're restarting. So now we want to use this triangle again so that we can get RB, but now we need to get BT. So what we now do a construction, do it in a different color. Oh no, that's actually with this purple. So we're going to now construct that line over there. We've also constructed AT, and then we're also going to construct something else. So now we've got these two triangles. And once again, we're going to go look at there. So we're going to say area of triangle RAB again, area of BAT. Okay. And once again, they're going to have the same height. They're both meeting up here at A, and then you're going to go 90 degrees to the base. Now remember, the baseline is here. So you're going to go at 90 degrees to that. So that's going to go there, and we'll call that H2. So we've also constructed H2 now. So now I'm going to start moving a bit quicker because you're seeing it's all pretty much the same. So now we're going to say half. Base is going to be BR, or let's say RB, because that's what they have there. And then we're going to say the height, which is H2. And then for the bottom triangle, we're going to take its base, which is BT, and then times its height, which is H2. And so what then happens is that these are going to cancel, these are going to cancel, and you're going to end up with RB over BT. So we're getting closer now. So I'm just going to neaten up over here so long. We've got area of triangle RAB over the area of triangle SAB. And we've now got that equal to AR over AS. And then for this one, we've got area of triangle RAB over area of triangle BAT. And that's equal to RB. Now, the only thing that's common in both, I want you to get that alone for both expressions. So you're going to say area of triangle RAB is going to become equal to AR multiplied by the area of triangle SAB AS. So all I did was I multiplied this up to this side. And then I'm going to do the same over here. So area triangle RAB equals to RB multiplied by area triangle BAT equals to RB multiplied by area triangle B, and that's all over. Now we've got this and we've got this, so I want us to almost like a simultaneous, I want you to make those two expressions equal. So we can make this equal to that. So we could say AR times the area of triangle SAB over AS. Well, instead of AR, I'm going to call it R8. And then we're going to make that equal to RB, area triangle BAT, and that's all over. So now what we need to do is, remember earlier we a triangle drawn over here, which was the SAB triangle. So what I want us to do now is ignore all of the top stuff at the top, and I just want you to look at the purple and the green triangle that I have drawn now. I want you to see that they both have this base AB. You see that they both have the same base AB over here. And can you see that they are in between two parallel lines? So that means that their height is exactly the same. Think about it. If you have a triangle, you have another triangle, they both go through, they are both going in between these two parallel lines, then surely their heights their vertical heights, because they are fitting in between those two parallel lines. Because those two triangles have the same base length, AB, and the same perpendicular height, then their areas must be the same, because area is a half base times height. But if your bases are the same length and your perpendicular height is the same length, then your areas must be the same. So we need to say that. We need to say of triangle SAB is the same as the area of triangle BAT. And we must give a reason. The reason is that they have same base and height. So you're literally going to say same and height, and that is because the lines AB is parallel to ST. It was only because these lines are parallel that we could say they have the same height, okay? So because these two triangles are the same now, we can ignore them. And so we then end up with RA over AS equals to RB over BT. And that is exactly what we were trying. In the diagram, O is the center of the circle. PWS is drawn, a triangle PWS with PW and S on the circle. OR is perpendicular to PS, ERS is produced to T, SW, Okay, here, this is important. OV to OT is 1 to 4. So OV to OT. Okay, so that means that OV is going to be 1x, and then O is going to be 4x. So instead of saying 4x, I'm going to say, so if this is 4, and this is already 1, then I'm rather just going to label VT as 3. Otherwise, it just looks ugly if I have to put a 4x over there. I'd rather just label this part as 3x. Okay, you understand that? So, first question for 5 marks, starting off with a bang. Prove with reasons OR to WS is 1 to 2. Prove that OR to WS is 1 to 2. Okay, that's actually going to have nothing to do with the 1x and the 3x. That's actually going to be all about this triangle here. So immediately when they said OR to WS is 1 to 2, so this one is going to be 1 and this is going to be double, I immediately thought of the grade 10 midpoint theorem, where if you have a scenario where you've got something like that, and you can show that this and this length are the same, which means that this is the midpoint, and this are the same, so that's the midpoint, then what it automatically allows, or what it means, is that these two lines have to be parallel, and this length is half if we have the midpoints on either side. So I mean like over here, and then over here are parallel, and the shorter one is half longer one. So if we can somehow show that this length and this length are the same, and this length and this length are the same, then we're good. So these two are the same, because this is the circle center, so that's a radius, and that's a radius. So we can say, first of all, that OP is the same as OW. And that's just because they are. Cool. So we've got the first midpoint. Now, one of the first theorems we learn about in grade 11 Euclidean geometry is that if you have a circle and you've got the center and you've got a line, and then you've got a line going from the center to that line and it hits it at 90 degrees, like we have over here, then that means it automatically cuts these two sides it cuts that line in half. So can you see we've got a circle center, the line hitting a line over here, and it's hitting it at 90 degrees. So it means then that this side must be the same as that side. So we can say that PR is equal to RS, and that is because we have a line. Yeah, let's write properly. Line, center. Now don't say to the midpoint. We don't have the midpoint. We have perpendicular. So we say line from center, perpendicular. And so we now can see that we've got this exact scenario happening. So then we can say, therefore, OR must be a half WS. So therefore, OR WS must be 1 to 2. And we must give a reason for that, sorry. We must say that now this one says, calculate the length of PT. T, where are you? Oh, there, okay, that whole thing. If ST is 15. Okay, so we have ST as 15, and we've also got this ratio over here. That means we can easily work out something about RS, because we could say RS over ST equals to OV over VT. I'll give the reason now, but we're working in this triangle, and we also know that these lines are parallel from the previous question, right? Because of that midpoint theorem. We should probably have added that. We can actually add that at the start of this question. We could say that ROR is parallel to SW, and that is because of also midpoint. Okay. So because we have a triangle over here that has parallel lines, we're using the proportionality theorem. So you could either say here prop theorem, and then you would say which lines are parallel, but what I like to use is line, parallel. Okay, so now RS we don't know, ST we know is 15, OV is 1x, and VT is 3x, so the x's cancel. And so you can multiply this 15 over, so you're going to get 15 over 3. So we now know that RS is 5. We don't have to say 5x or 5y, it's actually 5 units, and this is actually 15 units. Only these two here that are still x's. Now we already proved earlier that these two are the same, so we can then just say therefore PR, and we can just say proven from earlier. Now we know that this is 5, so now we know the length of PT. So PT, therefore PT is going to be 5 plus 5, 15, which is going to be 25. In the diagram, A, B, G, F lie on the large circle. A smaller circle is drawn that touches the larger circle internally at A. EA is a common tangent. Okay, so here we have EA as a common tangent, so it means that it's a tangent to the big circle and the small circle. EBCF is a tangent, EBCF. Okay, so there's EBCF. That's a tangent to the smaller circle over there. AC is produced, AF cuts, are drawn. Okay, so the first question, if angle EAG, so EAG, let me draw that for you guys. So E, the angle that is made, they have said that that is called X. Determine with reasons 4 other angles. Okay, immediately see 2 because of the tan chord theorem. If you look at here, we've got a tangent, right? Now let's look at the big circle. Here we've got a chord. Now where is the angle between the chord and the tangent? There it is, it's X. So we know from the tan chord theorem that if you have a circle, the tangent, and you have a chord, and then you have the angle that is in between those two, then that angle will be the same as the angle that that chord makes, like over here, okay? So if you look at this chord, where does it come together? Well, that whole angle, the whole of F would have to be X as well. So that's the first one. So we're going to say angle DFG, for example. You could also say AF. I just said DFG. It's the same angle though. That's going to be equal to X, and that's because of the tan. Okay, now using that same tangent, but use the chord only in the small circle. So now we are just operating in this circle. Now we've got the tangent. How did I do that? So okay, so something like that. So there we've got a tangent in yellow, and then we've got a chord over there, and then the angle is still going to be that angle over there. Put it more inwards. So if you can now look at that chord, which is over here, and you can see where does that chord come together in the smaller circle, that would be over here at D1. So just using tan chord in the small circle, we could say that D1 is going to be equal to X, and that's also because of the tan chord. Okay, so let's see what we have so far. We now know that this is X, and this whole angle is X. This whole angle EAG is also equal to X. And now the next one, remember they told us that this over here is also a tangent to the small circle. So if there's a tangent, here's a chord. So the angle between them would be that angle there, C1. And if you look at this chord, where does it come together? Well, it comes together at D1. So it means that D1 must be the same as this one. So now we're almost doing the reverse, not the converse, but normally we have this angle, or in the previous one we had the corner angle, and then we found the other one. Now we found this one, and so now we can say that that must be X. So we can say C1 must be X, and that's also because of tan. Okay, so there's the scenarios for now, and then we can just use vertically opposite over here. So C4 would be X. So C4 was X because of vert. Now this one says prove that, or prove the following. Okay, so immediately in my mind I'm thinking either this is going to be proportionality somehow, or it's going to be similarity. So what I'll do is I'll go find those sides. So AG is over here, okay, then AD is over, and then AC, it's the smaller one, and then AF. Okay, so that definitely looks like a proportionality, right? So have a look at this. Proportionality theorem only works if the triangles are, if they are parallel lines. But if you look in this triangle here, we can see that this angle and this angle are the same. So it's like having this. It's like having this angle and this angle the sgle. So if those angles are the same, those two lines would have to be parallel because that is corresponding angles. So that's where we can start. We can say that angle D1 is equal to angle AFG, and that's already been proven. Then we can say therefore CD must be parallel to GF, and we can just say that that is because the corresponding angles, so the corresponding angles are. Now that we know that these two lines are parallel, we can now go ahead and try to work this out. So we said that they have AG, they had AC. So it's definitely going to be, for example, like a AC over AG. You could also go AG over AC, doesn't matter. So AC over AG would then on the other side be the same as AD over, and then the reason for that, you can either say prop, and then you would say that the line CD is parallel to GF, or, and the one I'm using a lot more lately, is you say line parallel line parallel to 1. And so what we'll then do is we'll cross multiply, so you end up with AC times AF on the left and AD times AG on the right, and that's exactly what they wanted. They wanted AG and AD together. There they are. And then they wanted AC and AF together. Doesn't matter which is on the left and which is on the right, as long as these two are together like they have it, and then these two are together like that. Okay, this one, prove that this triangle is similar to this triangle. Okay, so AGF, so that's this triangle here. And then the other one is ABC, so okay. So let's just write this nice and big. They want A to be similar to a triangle, and triangle A. This X, by the way, is not part of the green triangle. That X is the whole thing over there, so don't get caught out there. However, this X here is part of the triangle, and this X here is part of the yellow triangle. So we can immediately say that they are equal. We can say that C1 is the same as angle DFG, and that has already been proven. Now, what's really awesome about when they give us the order is that it means that the A from this triangle, AGF, so that's this A3, that would be A3, must be the same as this one, because you see how they are both in position 1. So the A in this triangle, in the green one, is A2. Okay, so they're saying that those two angles must be the same. If you cannot see it immediately, then let's move on to the next one. So they're saying that G must be the same as B. So G in the yellow triangle, so that one, must be the same as B. Now that I can kind of see. Can you kind of see the bow tie sticking out? That immediately popped out. Check here. If we have, then can you see that bow tie effect over there? Okay, so, so we can say that angle B2 is going to be the same as angle G, and that's just because of angles in same. Okay, now we're good to go, because remember that when you have two triangles and you are trying to prove that they're similar, once you've already proven two pairs of angles equal, then the third angles, so in the green one that would be A2, and in the yellow one that would be A3. The reason that they are the same is just by saying sum of angles in triangle. So, and then we can say, therefore, triangle AGF must be similar to triangle ABC, and that is always because of angle. Okay, now, this one, prove that this ugly expression. So what I would always do is I would look at these previous two answers, and I would start there to try and make. Okay, so I would look at these two pieces of information, okay, and then also AG similar ABC. I know that when we've got that, then we can take this and we can make our ratios. So we can say AG over AB is going to be the same as GF over BC, which is the same as AF over AC, and that's just because we have similar. You could also say corresponding sides. Okay, so I see that we need GF twice. That's why there's a square. So I see we have a GF here, and I also see we have a, okay, no, we don't have a GF anywhere else. Well, that's an awkward start. But anyways, let's carry on. So I see we also have a BC, so I would just go circle any BCs that we have. FC, FC, do we have any FCs? There we go, and there we go. And then AD, there we go. Okay, so I think for now what I'm going to try is to take these two and make them equal. Then what I notice is that we've got a GF over here, and then we've got a BC and an AF. So I want to get this BC up here with the AF. The only way I'm going to do that is by multiplying this BC across, so you end up with AF times BC, and at the bottom we still have AC. So at least now we have the AF and the BC. I see that this AC is a little bit out of place because it doesn't exist. So I'm going to come up to the AC of this one, and I'm going to take this expression now, and I'm going to get AC by itself. So if I get AC by itself, it's going to give me AG times AD over AF. Okay. I like that. Okay, well, let's first see how that works out. So I'm going to go plug AC then as AG times AD. Now, whenever you have a fraction like AF times BC, think of it as over 1, and you divide that by another fraction, which is AG times AD over AF, I would use the multiplication and then you flip over rule. So you multiply, and then you flip this over, so it's AF, and then AG times AD at the bottom. So that is what we're going to end up with then for GF. We're going to end up with AF times by BC, then at the bottom we've got AG times AD. And so what I noticed is that it doesn't seem like we're getting any closer. So this can definitely happen. I promise you I cannot see the answer at all. Yeah. Even though I've been doing this for many, many years, I can't just look at it and be like, okay, that's how it's going to go. Now we go back to the drawing board. Now what I do is I would be like, okay, maybe we're going to use one of these and then combine it with something totally new. So then what I would do is I'd go look at GF and I'd go find it on the diagram. So GF is over there. And I would look at BC over there and FC and AF and then AD. Okay, so even with that, I don't feel comfortable that we got anywhere further or got into anything. Something else we can look at is this GF squared. That's the one that's been sticking out to me a lot. That means that the GF has to appear twice somewhere. What we need to understand is that sometimes when you have two triangles that are similar and they both use GF, that is one way that you could get a GF squared. So what I then thought we should do is we look at GF, a triangle that has GF. So the two triangles that have GF would be, and then whole triangle over here. If we could somehow prove that those two triangles are equal, then we can see that they both have a GF. So when we do the cross multiplication a bit later, we might get the GF squared. I tried getting a GF squared out of these ones, but it wasn't giving it. So let's try this. So let's see if those two triangles are similar. Well, they definitely share angle G. So we could say angle G is equal to angle G, and that is common. Let's first say what triangles we're working in. In triangle in triangle AGF and triangle CFG. The order doesn't matter for this part, eh? You're just telling the examiner which triangles you're working in. So we could say that angle G is equal to angle G, and that is because they are common. And I can see that there's an X over here, and there's an X over here for that whole angle there. So then we can say C4 is equal to angle G, so that's this whole angle, or let's say GF A. Doesn't really matter, but that's this whole angle here. And that we've already proven. We showed that they both equal to X. So here we've already found two pairs that are the same. So we know by now that in similarity, if you already found two pairs that are the same, then the third pair has to be equal because of sum of angles in a triangle. So what haven't we used? Well, in the yellow triangle, we haven't used F, and in the green triangle, we haven't used A3. So they would have to be equal because of the sum of angles. Therefore, the two triangles are actually similar. So I'm going to put the first one as A. Now I have to make sure my order is correct for the next part. So AGF. So A went with F2. We'll put F over there. And G in AGF, which is this one, went with G in the other triangle. And then the only other missing side for this triangle is F, G, and C. And that's going to be because of angle, angle, angle. Okay, so now we can go make our ratios with those. So let's go make our ratios now. So we could say AG over F equals to GF over, which is equal to AF. And the reason for that is because they are similar. Okay, so here we can see there's the GF twice. We can just rewrite that as GF, FG, FG. I mean, FG, GF doesn't make a difference. Now I'm going to use cross multiplication. So you're going to end up with AG times GC equals to GF times GF, and GF is just GF squared. So I just cross multiplied with those. So now we have a GF squared, like we predicted. I'm just going to write it the other way around. So we now have, there is no AG and GC over here, but here we have an AG and GC. If we look at some of our earlier information, actually first, if you see here, we're trying to get, we want to get an AD in our answer. So we could get that from AF and AD over there. And we could do that by getting AG alone. We could get AG alone over here because then we could replace it over there. So we could take this expression now and we could get AG alone. So AG would then be equal to AC times AF. We could then replace that over here. So we then get GF squared equals to AC times AF over AD. And that's all multiplied by GC. So we can just have... Okay, so now we have the AF, which is what we want. We have AD. But what we don't want is AC and GC. Now, I don't see any AC... Well, I see a GC, but I don't see AC over here. What I would then do... These are very complicated questions. I would then say, okay, we don't want AC and GC. Now, AC and GC are and there. So we don't want those. And what we still need in the answer is a BC and a... Okay, we've got the AF, we've got the AD, and a FC. So we're still looking for a BC and a FC, so a BC. So can you see two triangles sticking out there? Well, I can see this triangle and this triangle. Those are the two triangles that I can kind of see when I highlight those. So what I'm going to try to do is prove that those are similar. So in triangle CB, triangle EF, the order doesn't matter there. You're just telling the examiner what triangles you're using. Okay. So we can definitely see that these two are equal because of vertically opposite. So we can just say C1 equals to C4. Earlier, in one of our earlier questions, we proved that these two are the same because of angles in the same segment. So we can just say G is equal to B2 because we already proven that. There we've already got two pairs. So the third pair has to be equal because of angles in the same, sum of angles in a triangle. So that could be this one over here, which we haven't used. That would be angle A2. And then in this triangle, we haven't used. And so that would be sum of angles in a triangle. Therefore, the two triangles are similar. So ACB, now we got to get the order right. So ACB, so A in this triangle was the same as F2. So that's going to be F. Angle C in this triangle was the same as angle C in this triangle. And then angle B in this triangle was the same as G. And that's because of angle, angle, angle. Now we're going to make our ratios. Very, very challenging question, but these last questions, very often they are like this, where you just have to play around. But very often you're not going to end up having enough time in the exam. So it is quite a stressful scenario because you can't really think when you're super stressed. And that's going to be because of similar... Okay, so we said that we had this expression. We said that we don't want AC and GC. So we don't want AC and GC, but we do want BC and FC. There's BC and FC. So we're just going to go take these two now, cross multiply, so we end up with AC times CG equals to BC multiplied by FC. And so there we have AC multiplied by GC. We can get rid of that and we can replace it with BC times FC, which is what we want. So we can then say that GF squared is going to be equal to AC times GC, which is now BC times FC, and then we still have the AF, and then we still have the, and then we have very difficult, very challenging.